Hi everyone, welcome to Beyond Semicolon, 100 programs in C series. Today we are going to see an interesting topic called sparse matrix representation using arrays. First let's understand what is a sparse matrix. If you observe this matrix, it is a size of 6 by 6 and it contains mostly zeros, only few non-zero elements are there. Non-zero elements are 1, 1, 2, 1, 1 at different rows and different columns. Instead of wasting memory storing all the zeros, likewise here total 36 elements are there. If each element takes 2 bytes of memory, we are consuming 72 bytes of memory. And if you observe, total non-zero elements are 5. 1, 2, 3, 4, 5. 5 elements are there. To store 5 elements, you are actually require 10 bytes of memory. Sparse matrix representation matrix would be 5 plus 1 number of rows and 3 columns. Let us see how we arrange the values. In the 0th row, in the 5th column, we are having a value. So what we do, in the first row, we mention 0th row, 5th column, we are having the value. That means here 0 column represents row, 1 represents column, 2 represents value. In the first row, 3rd column, we are having 1. That is first row, 3rd column, we are having 1. Again, in the first row, 5th column, we are having 2. First row, 5th column, we are having value 2. In the second row, 5th column, we are having 1. Second row, 5th column, we have 1. In the third row, we don't have any values. In the fourth row, we don't have any values. In the 5th row, 0th column, 5th row, 0th column, we have value 1. So this complete 5 values we have represented in the matrix. We must be able to reconstruct the original matrix from this sparse matrix representation. Yes, we may get a doubt now. Sir, how do I know if I give this matrix, the generated matrix, how do you know how many number of rows and columns are there in the first row? Right? First matrix. So we mention in the 0th row, the total number of rows are 6 in the original matrix, the total number of columns in the original matrix are 6 and total number of non-zero elements are 5. If you look at 0th row, we get the details of complete original matrix. Likewise, 6 number of rows are there, 6 number of columns are there and 5 non-zero values are there. Let us understand the logic how to build this. Let's trace the program step by step. Always remember, don't by heart the concept. Try to understand the logic behind every program, and when a data is given to the program, what is happening to the program what is happening to the data inside the program matters a lot. If you understand that, half of your problems towards the programming is solved. If you observe int, first in the 5th statement, rows, a memory block is given for the rows and columns. If I give 5 as the rows, that means we are going to store 5 rows and 4 columns. And there are another 3 variables I, j and k. So k already a value is assigned, that is 1. Here matrix we are assigning the size 5 comma 4 and sparse matrix 20 comma 3. Here enter number of rows and columns. Here we are assigning the value 5 comma 4 and after that let us understand the main logic behind how you convert or represent a sparse matrix using arrays. I kept the logic in a separate page so that it will be easy for us to trace. Initially, 12th statement, for I is equal to 0, I less than rows. So consider like number of rows is 3. So let us consider rows is equal to 3, columns is equal to 4. I is equal to 0, I less than 3. After that, it enters to the 13th line. In the 13th line, for j is equal to 0, 0 less than 4, 4 is the column. Next, scanf, that means it is taking input from the user and it is assigning to the matrix I comma j. I value is 0, j value is also 0. Let us consider we are assigning the value 0 here. So 0 comma 0, 0 is assigned. In the 15th statement, it checks with a condition. If matrix of 0, 0 not equal to 0. Is the condition true? Matrix 0 comma 0 is 0 where the condition is failed, so it does not enter inside. Now it goes back and updates the j value, j plus plus. J is equal to 1. 1 less than 4. Condition is true. It goes to the 14th line. Matrix of I comma j. I value is 0. J value is 1. Let us consider I am giving an input as 3. 0th row, first column, value 3 is assigned. It goes to the 15th statement. If matrix of 0th row and first column is not equal to 0, the condition is true. Since the condition is true, it enters inside. Here we will be having a separate matrix that is for sparse matrix. 0, 1, 2. 3 columns will be there. 0, 1, 2, 3. Number of rows will be on the basis of how many non-zero elements are there in the original matrix. Since the condition is true, observe here the core logic sparse k. If you remember in the previous slide, I mentioned k is equal to 1. 1 of 0 is equal to I. I value is 0. Then sparse of k comma 1. K value is 1 and 1. In the sparse matrix, first row, first column will be assigning j value. Currently, what is the j value? J is equal to 1. So here 1 is assigned. If you observe, this represents in the 0th row and first column we are having a value. What is that value? Matrix of 0 comma 1. So I will write it here. Sparse k value is 1 comma 2 is equal to matrix of I comma j. I value is 0, j value is 1. That means matrix of 0 comma 1 is 3 is assigned to sparse of 1 comma 2. Now it goes back, updates the j value, j plus plus. Again it executes the 13th line. J is equal to 2, 2 less than 4. Condition is true. In the 14th statement, it takes the input from the user. Matrix of I value is 0, j value is 2. If I assign the value 0, 0 will be placed here. The moment I assign the 0, it goes to the 15th statement and checks with the condition if matrix of 0 comma 2 is not equal to 0. The condition failed because, not equal to 0, the condition failed. Since the condition is failed, it does not enter into the if condition. Go back and updates the j value, j plus plus. Again, 13th statement, j is equal to 3, 3 less than 4. The condition is true. Enters inside. Matrix of I comma j. I value is still 0. That means still we are in the 0th row. And j value is 3. So we are entering a value in the third column. So third column value, if I assign it as 0, it comes to the 15th statement. In 15th statement, if matrix of I comma j, I value is 0, j value is 3, not equal to 0, the condition failed. It goes back, updates the j value. When it updates the j value, 13th statement, j is equal to 4. 4 less than 4, condition failed. Since the condition is failed, inner for loop exited completely and goes back to the 12th statement. In the 12th statement, what is happening? In the 12th statement, I plus plus, from here it goes, updates the value I plus plus. I value becomes 1. 1 is less than 3, condition is true. Again same story repeats. In 13th statement, int j is equal to 0. So we entered into the first row and 0th column we are concentrating. 0 less than 4, condition is true. Since the condition is true, it enters inside and checks with the 14th statement. Matrix of 1 comma 0. Matrix of 1 comma 0, if I am assigning the value 0 to it, so first row 0th column 0 is assigned. 15th statement. If matrix of 1 comma 0 is not equal to 0, the condition is failed. The condition is failed. It goes back, updates the j value, j plus plus. Again 13 statements get executed. J is equal to 1, 1 less than 4, condition is true. Goes to the 14th statement. Matrix of I value is 1, j value is 1. That means first row, first column. If I assign a value 5, so in the first row, first column 5 is assigned. And 15th statement, if matrix of 1 comma 1 is not equal to 0. Yes, it is not equal to 0 because value 5 is there. It enters into if condition and it executes the statement 16, 17, 18. Sparse matrix of k, oh, I missed a point here. Here it updates the k value, k plus plus, k value is updated to 2 currently. Sparse of k value is 2 and 0th column is equal to I. Currently I value is 1. That means sparse of second row, 0th column, the value is updated to 1. That means it represents in the first row there is an element. Need to update the column number also. Sparse of k value is 2 comma 1 is equal to j. Currently j value is 1. We mention here in the second row, first column, 1 as the answer, 1 as the value. What does it represents? First row, first column of main matrix, it has a value. What is the value that it is having? Matrix of 1 row and the first column. Let's update that. Sparse of 2 comma 2 is equal to matrix of first row, first column, which is nothing but 5. 5 is updated. Got it? Similarly, it keeps moving inside and it updates all the values. By the time, let us consider we are having value something like this. You will have second row, third column value as 1 and k value will be updated to 3. So this k value represents total number of values that are non-zero in the main matrix. Our next job is to update sparse matrix representations 0th row, right? If you observe, sparse matrix of 0th row and 0th column, number of rows is 3. So 3 is updated here. Number of columns 0 comma 1. In the 0th comma 1 position, we are updating number of columns, that is 4. And already k value is there that represents total number of non-zero values that will be updated here. So this is the sparse matrix of the original matrix this is the sparse matrix representation using in C. This is sparse matrix representation using arrays in C. So what you are supposed to do, trace the rest of the program, understand the logic. In next program, we are going to see how to add 2 sparse matrix. Thank you.